Hello, this video will show you the process to simulate your circuit using the Quartus simulator. Okay. So we're going to reuse example number 1 from previous video. To restore the project, click File, Open Project, go to My Computer, Local Disk, 2001, Hardware, Example 1, that's the file. Click Open. In order to simulate your circuits, you must compile your project. If you have previously compiled the project in a different video, now please recompile the project. Double click this arrow, we'll start the process. Okay, the compilation was successful. So now you can start the simulation of your circuit. To do that, click Tools, Run Simulation Tool, Gate Level Simulation. So this is the simulation tool. It's called ModelSim. It has 3 primary windows: library, waveform, and transcript. The library tells you what kind of library you have in the workspace. The waveform shows you the waveform of your circuit, and the transcript is for you to enter commands to simulate your circuit. Okay, this simulation tool is command driven. You need to type in the commands. Okay, so to start simulation, you need to click Simulate, Start Simulation, and you select the circuit you want to simulate. In this case, under Gate Work, this is your circuit. The project is called Example 01. Okay, you click on that, you select the resolution. You either pick nanoseconds or microseconds. Okay. If you have a circuit which has no clock, you should use microseconds. If you have a circuit that has a clock, you should select nanoseconds. Okay, So our example does not have a clock, so we'll pick microseconds as the resolution. You click OK. Right. Now you are in the simulation environment. Under View, make sure that you check the wave so you can see the waveform window. If you don't check it, you will not see the waveform window. Okay? So there are 4 types of commands you need to type. You need to add the inputs to the waveform. You need to add the output to the waveform. You need to assign values to your input, and then you need to run the simulation. Okay? Since there are 4 inputs in this example, there are total 16 combinations for the truth table. We will enter 4 values at a time using the commands, and then we'll simulate 4 different values at a time. Okay, so in total we will have 16 different values. Okay. What I recommend is to start the notepad and use this to type in your command and then copy the commands into the simulator. To add inputs to your waveform, you need to use this command. All commands are lowercase except your input, which usually are uppercase, and your projects usually uppercase. So the waveform command is add space wave space color. In this case I use line, item color line, format binary, simulation colon project input. Okay, so let's copy this and paste into the transcript window. Right click, paste. You can see that your input A is added to the waveform window. Okay, so let's do the same thing for input B. So the command to add B is very similar to A. C, and B. So you have added 4 inputs. So now we'll add the outputs. I recommend to use a different color for your output. In this case, I'm going to use red color, like this. So my inputs are green, my output is red. You can use blue, you can use orange. Okay, so we have completed adding the inputs and outputs to the waveform. Now we want to assign values. To assign values to input, you need to specify the input values at different time. Okay, to do that, we need to use the force command. So look at this command. This command is the force command. This set of values means at 0 microseconds I want 0, 1 microseconds I want 0, 2 microseconds I want 0, and 3 microseconds I want 0. 2 pound means binary, 0 means 0. So this means binary 0. Okay, so let's copy and paste. Okay. We do the same thing for B, C, and D with different values. So looking at these commands, B is 0, 0, 0, 0. C is 0, 0, 1, 1. D is 0, 1, 0, 1. Okay. If you have a syntax error in the command will not execute, and you'll get a red error message from the transcript window. Then you know something went wrong. Okay, so far everything is working. So we have four different values already. Next, we need to run the simulation. Looking at the command, we see that each value takes 1 microsecond. Since we have 4 different values, we should run the simulation for 4 microseconds only. So run 4 microseconds, copy and paste, execute. So now the simulation just completed 4 microseconds. By default, you are all the way zoomed out, so you need to zoom in to see the values. To do that, you click on the waveform window, you click this button here, click, these are your values. So you can see that 0, 0, 0, 0, 1, 0, 0, 0, or if A is your MSB, it will get 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and that's the output in red. Okay. If you want to zoom out, you can use the minus button, then you can zoom out. If you want to zoom in, you can use the plus button to zoom in. Okay. Well, this will zoom everything. Let's put down additional 4 values for the input. Pay attention to the time. Right now, your simulation time is 4 microseconds. So anything happens after this will be referenced to 4 microseconds. Any additional values you provide will be referenced to 4 microseconds. Okay, so you look at these values. The values, it's for A will be 0, 0, 0, 0, B 1, 1, 1, 1, C 0, 0, 1, 1, and D 0, 1, 0, 1. And we are going to force these values, copy and paste, and run for additional 4 microseconds. Enter, click, zoom, so you can see the values are 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, and 0, 1, 1, 1. So the simulation time moves from 4 microseconds to 8 microseconds. We're going to assign additional 4 values to the input like this and run it for 4 microseconds. Okay. So assign the values, and run for microseconds. Zoom. Now you get 12 different values. Okay. So total we need 16. Now we have 12. We need 4 more. These are the last 4 values. Okay. Copy and paste. So my simulation time is 16 microseconds now. And these are the 16 different combinations. So they represent your truth table. Now you can check your truth table against the waveform. You can also use the cursor to indicate the value. As you're moving the cursor using your mouse, you can see the values will change. So the values are listed here. The cursors can move from values to values. Okay? If you want to export this waveform into an image, very easy. You go to waveform window, click File, Export Image. So let's put it on a desktop. Let's call this ex_01.bmp. Save. So this waveform will be exported to the desktop. So let's go to desktop. We can see the file here. If you double click, this is how it looks. It has the time scale horizontal. It has your cursor locations and the inputs, outputs, and the waveform itself. So this is a good documentation of your circuit's behavior. Okay? Alright. If you're done with your simulation, you can go to Simulate and Simulation. Confirm. Yes. So you are out of the simulation environment. File, Quit. Confirm. You are back to Quartus Prime. If you make changes to your circuits, you need to save your project, recompile your project, and restart the simulation. The simulator will not know you made changes. Okay? The moment the simulator starts, it will try to simulate the last copy of your project. Anything happens after you start the simulator will not reflect in the simulator. Okay? So pay attention to these commands. We have commands to add inputs, commands to add outputs, commands to assign values to inputs, and commands to run the simulator. Okay? So this concludes our demonstration of using the Quartus Prime simulation tool to verify your design. Thank you.